serious. Okay. Wow. So what's going on? Can you all hear me now? Can you hear me now? I think you can actually hear me now. I'm sure you can hear me now. Please, can you hear me now? Can you hear me now? Is it? I think it's better now. You can hear me. Can you hear me? Okay, that's good. Thank you so much. So, thank you so much for calling my attention to that. God bless you. I'm going to take everything from the beginning one more time. I said that this class is Python for data visualization class. And so for some of you, I sent a mail across, and then I sent some videos, useful videos. Okay, if you really registered, I believe you got the mail. So, and I believe you were able to watch the NumPy primer and the Pandas primer, and you also were able to read up the other link. Okay, if you did that, I believe you will have enough knowledge during the hands-on practice. And also, I created a Telegram group where you can actually join. And in that Telegram group, I'm going to handle all your questions. And while you're trying to practice, because we're going to have an exercise in that Telegram group, I will be there to help you practice and share what you learned from the class. So that's important information. Then also, I introduced myself. My name is Anigo Tobias, but I love being called Coach Toby. Okay, and that's okay. Now, this Python for data visualization. Now, in this class, we're going to cover what Python for data visualization is, libraries, and what do I mean by libraries? They are just packages you can use for data visualization. Okay, and then we're going to go through plot and chart you can make, and then we're going to practice. I believe you love the practice part. So let me continue. And the next thing is this. So, what is Python for data visualization? It refers to the use of Python programming language and the libraries just to create graphical representations of data. So if you're able to make use of Python to create graphical representations of the data you have, you're already doing Python for data visualization. That's what it is all about. That's Python for data visualization. It's not such a big deal. Now, what are the applications of this thing? Okay, it has a wide application both in business, in science, in finance, education, sports, and entertainment. What do we make use of it in business? That's if you want to go through your sales data or maybe customer data or something like that. With Python, you can actually analyze your sales data, analyze your customer data, try to find insight from it. So, example of plot, you can make it pie charts, trends, and all. Even in science, you can make use of a particular package known as Matplotlib or Seaborn to create 3D charts. I'm serious. 3D charts and all of them, the likes of them. And you can, let me say you want to write a research project to gather data. You can make use of the knowledge here to analyze your data and, okay, do your, whether it is undergraduate, master's, PhD research with the knowledge. Also in finance, in education, even sports analytics can be done with Python, and then also in entertainment and media. Now, what are the tools you can actually make use of? I don't know if my screen is quite wide, but let me try. I hope you can see my screen. The tools you can make use of: Python, the language itself, Pandas, NumPy, Matplotlib, Seaborn, Plotly, Dash, Alter, GeoPandas. GeoPandas is very, very useful if you are into GIS and the likes of them. Then there is also Bokeh. Now, right here on the screen, I clipped some charts that I'm trying to show you examples of charts you can actually make. Okay, somebody says he registered but didn't get a mail. Okay, what's going to happen is but didn't get a mail. That's serious. Okay, if you register but didn't get a mail, I'm going to try to go through my chat. I'll send a mail right again to you. Don't I've taken note of your name. I'm going to search. If that's the name you registered with, I must send the this thing, everything back to you. Okay. And these are examples of charts you can make with this. You can make charts like this. Now, if you remember, when I began the class, I said after going through the plots and charts, we're going to practice and I'm going to show you some live things. So let me show you this. I want to show you this now. Uh, So here is it. Now, in the message I sent to you, I told you guys how to actually open a Kaggle notebook. So in this particular class, we are going to make use of a Kaggle notebook. What's a Kaggle notebook? And a Kaggle notebook is a notebook in the cloud. Not many persons know about this. So for some persons that are going to complain, why you're not doing data analysis with Python, will say, my laptop is not so good, oh, my laptop does not have a high memory, oh, I cannot download Anaconda, I cannot download Python, I cannot download VS Code. Now, instead of you complaining, there is a solution. And what is the solution? The solution is there are what we call cloud-based notebooks you can actually use. For example, there's a Jupyter notebook in Kaggle and it's in the cloud. You can make use of. And the good thing about this kind of notebook is that you don't even need to download Python. You don't need to download some libraries. They're already there within the notebook. So, and that is why I reviewed this secret to you paper. I said, okay, go ahead, open your own notebook. So this is how to open a notebook. If you have already signed in, which I encourage you to sign in, you're going to see a tab like this. So in that tab, you can click on code, which I'm going to do now. When you click on code, you are going to see new notebook. And then when you see new notebook, you can click on the new notebook here, and it's going to send you to a particular page where you have your Jupyter notebook. We are going to do that. But before I do that, let me show you examples of what people have done in the past using data visualization in Python. I don't need to reproduce them. We have many of them in Kaggle, a whole lot of it. If you look at this particular notebook, you can see the libraries I mentioned: Matplotlib, Seaborn, Plotly. Now here are examples of this thing, of charts they were able to create. Right here, you can see what this is. This is a chart, right? Now this a particular plot, and the plot contains a count, unique, and frequency of the data they have here. If you are lost at any point, draw my attention to the comments. Okay, so these are the example of what you can do. Here, this person created some bar chart trying to represent data. For example, this someone's chart. Anyway, it's not mine. It's just right there on Kaggle. I said, okay, let me show you using what someone else has done. You can actually make word cloud, okay, with Python for data visualization. You can make word cloud, something like this. Some of you must have seen it. Let me bring up another example. So it's something interesting. This advanced potato disease detection. The person created some charts. Or let me make use of the popular one, Titanic. Let's see what this person did here. Now the person made use of these notebooks, and this is the data. This is a data set. Actually, the person imported this data set containing name, sex, age, and some information. And then the person was able to create, let me go to charts like this. This, a bar plot created with Seaborn. So number of males, number of females, all summarized. Females that survive, males that survive. Now, I think this is one of the things you can actually make use of in your research projects. Okay. So let me also get another example, a more robust example. Uh, okay. So let me. So having done that, let me check here. Having done that, I believe by now, okay, by now you've seen examples of things people can make. So in this class, here's what I want to accomplish. I want to give you a good knowledge of what you can do with Matplotlib. Now, Matplotlib is just one of those packages in Python for data visualization. So if you are with your laptop, I will encourage you at this point to just go right now, open your Kaggle. You can split your screen, open Kaggle somewhere, and let me guide you so you can do what I'm doing exactly. At the end, I'm going to release my notebook to you so you can actually go ahead again and repractice. So when I click on new notebook, it's going to open to this. Yes, let's get it exactly. When I click on new notebook, I'm going to have a notebook like this. And right now, all I need to do is just to start working. Now, in Jupyter Notebook has what is made up of cells. So each cell can contain either a code or a text. So in this case, I'm going to remove everything right here, and then we kick off with the project. Now let's continue. So I'll change this to Markdown. Markdown is when I want to put, okay, no. So now, okay, introduction, this covers also. In this introduction to Matplotlib, here's what we're going to go through. We're going to import necessary libraries. We're going to make a linear graph. I'm going to guide you on two ways of making use of Matplotlib. We're going to make a quadratic plot, label the quadratic plot, annotate the graph and all. Now let me continue. So as I taught you earlier on, one of the best things to do whenever you have, the first thing to do is this: always import libraries. Always import what? Libraries. So we're going to import pandas as PD. We're going to import numpy as np, and then we're going to import matplotlib pyplot as plt. If we do this, I'll just run this, and then, okay, what's the problem? Pyplot. Okay, I made a mistake here. Yeah. So I have already, by doing this, I have already imported the libraries I'm going to use here. As I taught you, libraries are the packages itself. Like, that just, let me say you have a big toolbox. So you have spanner, plier, and all. So it's just part of those tools you're going to make use of while trying to do data visualization with Python. Those are libraries. So pandas is a library for data manipulation. NumPy is also another library for mathematical manipulations in Python. And then Matplotlib is for visualization. So let me run again. Pandas for data manipulation, NumPy for mathematical functions and manipulations, okay, like square roots and all. And then Matplotlib for your data visualization, that visualization package. Now, having done that, the next I'm going to show you is this. Sorry, because of our time, I won't really type everything. For some things, I'm going to just paste them. Now, if I want to add a text, look at what I'm going to click. I'm going to click on plus markdown. When I click on that this way, I'll paste a text, and then I'm going to run the text by clicking on this thing, run current cell. Now, what do I want? Why did I add that here? There is something we call a linear equation. If you look at this thing here, I said this is a linear equation. B is equals to 2x plus 6. Now, if you did basic primary school mathematics, uh, from basic school primary math, or not primary, but secondary mathematics, we know about linear equations, 2x plus 6. Okay, we might have something like y is equals to 2x plus 6. And then the teacher will say, when x is equals to 2, what's going to be the value of y? Then you can go ahead and say 2 times 2 is 4 plus 6, 10, right? So, and you can actually get different values of y when you have different values of x. So in that case, y is the dependent variable and x is the independent variable. And I can remember in our junior class then in school, we were even able to plot some linear graphs in a particular graph or something like that. Do you know we can do that thing with Python? Now, let me show you how you're going to do that with Python. If you want to do that with Python, it's not very, very difficult. Now, the first thing you are going to do is you are going to create the values you need. What did I say? You're going to do what? Create the values you need. Now, let's go ahead and create the values. A is equals to mp dot linspace. I will explain everything. Linspace and -2, -4, -2, 4. Okay, and next is going to be b is equals to b is equals to okay, so let's go. So what did I now in this particular case? Our x is, what am I trying to do with this? What I'm trying to say here is that this particular code here, the one on top, I want it to create, I'm going to use this. I want it to create this to generate values -2 to -4. That's from -2 to from -2 to 4, 7 values. So we're going to have -2, -1, 0, 1, 2, 3, 4. How many values? 1, 2, 3, 4, 5, 6, 7. That's exactly what that code is going to do. So I'm saying numpy dot linspace. Remember we imported numpy as mp. So I'm trying to say mp dot linspace. Now linspace is a particular method of numpy or a function in numpy. So I'm trying to call that function, asking the function to create values from -2 to 4, 7 of them. So it's going to go this way: -2, -1, 0, 1, 2, 3, 4, 7 values. Now, what's the second line of code for? The second line of code is now to generate different values of y. To generate what? Different values of y. If I put -2 as x here, that means 2 times -2, -4 plus 6. That's going to give you 2. 2 times -1, -2 plus 6. That's going to give you 4. So just like that. So already you've seen that for you to really enjoy this class, at least you must have a basic knowledge of mathematics. So that's it. Now I'm going to speed up everything. Let's go with speed. Now when I do that, the next line of code is this. Now please still stay with me. I noticed that some persons are leaving, but let me quickly speed up everything so it's not going to be that boring. Now right here I have a very linear plot. Now let me explain this line of code. I've been able to plot the values I told you about. Okay, so if you look at this value on the y-axis, we have the value for y. Okay, and then on the x-axis, you can see on the x-axis I have values from -2 to 4, from -2 to 4 on the x-axis, and on the y-axis I have values from 2 to 14. So this is a linear graph. This should bring your mind the graphs you plotted back then in school. And then right here, what I have here is called the title. This is called axis label. This is called axis label. This is called the plot line. And then that is it. Now, how did I bring up those things? I'm going to explain the code. The first part of this code is to set the plot layout. So I'm trying to tell you that the figure size should be 5:5 and the layout should be constrained. Then I'm also trying to, then the next thing is to plot it, to make the plot itself. So how did I make the plot itself? Now that's the information you have here. The information you have here is for the plot itself, okay? So the value of A and B, that's the B here is value of Y, and the A here represents the values of X. That's what you have here. So the label is linear, and that is this thing you can see here. Label the X axis, plt.x label. What's plt? plt is matplotlib. So when I call plt.x label, it's going to give this X label X axis. And when I call plt.y label, it's going to give the Y label Y axis. And then when I say plot title is a linear plot, that is what you have here on top, okay? And then when I say plot legend, that is this one. I do believe that at this point you have gained an understanding of how to reproduce a very, very simple chart like this. I have only 4 persons watching, okay? So let's continue, let's make progress. And the next thing I'm going to show you, please, if you have any question, I'd like you to drop. If you are still following, please drop a comment. Please drop something in the comment section. If you are still here, you are following, please let me hear you. Let me get you in the comment section. If you are following the class, let me get drop something, put something down in the comment section while I continue. Now, in the next example, I'm going to show you how to make a quadratic plot in the next example. What is a quadratic plot? We all know what a quadratic equation looks like, right? In a quadratic equation, the power of x is raised to square. What I'm covering right now is very, very important for those that are in science, right? If you are going to do research, definitely you are going to make plots like this. So please pay attention and don't start going away. Don't start procrastinating. It's too early to procrastinate. So now let me see fasten things, okay? So if I want to make a quadratic chart, a quadratic plot, we need to first of all understand that for us to make the plot, we need to bring up a quadratic equation. And from our secondary school mathematics, I want to believe everybody here, you have that knowledge in secondary school of making quadratic charts. So we know that in a quadratic equation, the power of x is raised to power of 2. Yes, that's quadratic equation. So right here, if you can look if you look at this thing here, you see that the first code is for the values of x, and it's same thing from -2 to 4. That's -2, -1, 0, 1, 2, 3, 4. Then for the values of y, what the equation I have here is 2x squared minus 5x minus 6. And if you have that knowledge of mathematics, you must know that there is part of those common quadratic equations you get to see in mathematics. Now here is how you're going to make that plot. Let me quickly show you. I will no longer try to code from scratch everything because of our time. I won't try coding from scratch, but I'm going to explain this code. Now here is what this code covers. The first code is to create the plot. plt.figure. Where am I getting my plt from? Plt is from this plate. Import matplotlib.pyplot as plt. That's where we got the plt from. So back to this plate. plt.figure. It's a function of matplotlib that helps you to set the size of your chart. This is as if you got a graph book and you want a specific size of graph book. Okay. Now, plt.plot is a particular function that will go ahead and make the plot itself. So right here, we're trying to tell it the value of x here should be plotted against the value of y here. And then the label of the plot is quadratic. We want it to know that this is a quadratic equation. The next line of code is to give a label to the x-axis. That's plt.x label. What do we want to see on the x label? X-axis. Next one, plt.y label. What do I want to see on the y label? Y-axis. plt.title. That means the title of the plot should be a quadratic plot. Okay. And then what is the next line? Text. Text is equal to arrow. That's this particular thing is a text that's going to appear in the chart. I'm going to show you that it's called a math text function. Okay. And if you are part of the Telegram group, I'll show you how to really write in Matex. We can't cover that in this few hours class now, it's a few minutes class. Then what is plt.text? What's that line of code all about? This line of code. Now, this line of code is going to give your text a particular location in the chart. So here is the location of the chart of the text, this text now in the chart. Now, this text is this particular value. It's going to bring it into the chart, and then the font size is going to be 10, and the VA is bottom. That's where it's going to rest. So plt.legend is going to show quadratic plot on that quadratic on the particular chart. So when I click enter, let's see what we're able to make. What's the problem? Okay, I need to change this. I need to change this to. It did not run because I added. Okay, so put it in a code. Click enter. When I run that, unexpected indent. Okay, X is not defined. Okay. Now, can you see the plot I have here? I don't know if you are still following. You can see the plot right now. This is a plot. So I now have a quadratic plot, and this like that kind of thing we make in secondary schools. Then it looks like this, somehow a bit rough. Okay, and so you can see all those things I mentioned. This a quadratic plot. That's this here. Y-axis. That is this here. X-axis. That is this one here. Okay, and then quadratic. This particular legend here, this thing here, is because I said legend and I gave a label. And then the text itself, you see this thing here, this particular thing here. Now you see that's what you have here. Y is equals to 2x squared minus 5x minus 6. Now that is the quadratic equation that we made a plot of. So this is what you can make with matplotlib. It means you can actually make this example of people in the science field do. You can make a similar plot, okay, using matplotlib. So if you're writing a master's degree project, PhD or something, it's an introduction of what you can actually do. Now let's go ahead and make this particular chart look more appealing. For us to make it look more appealing, there are other things I'm going to add to it. And the first thing I'm going to do right now is I am going to generate more values. I'm going to generate more values so that the curve is going to be smooth. Let me quickly copy a code where I did that somewhere and paste it here. So I'll go here, click code under here, and then I paste. Let me explain. So in the previous part, we just generated how many data points? I generated just 7 data points for my X and O. But in this particular example, I want to generate more data points. I want to generate 100 data points. Okay, my equation remains the same. By now, you should be familiar with all the things I have here. But what is the difference? The difference of the between this one and the previous one is that in this one, I'm adding grid line. Here's what we call a grid line. A grid line that's it's gonna make it look like a graph. And then I also added plt.xticks and yticks. So the xticks and yticks, it's just one of the things we do. Then they say, okay, draw to scale. You're trying to scale the y-axis and the x-axis. And then a legend, we know what a legend is already, and plt.show, just to show the plot. We've done something like this before. Now let me go ahead and click enter. If I click run, it's going to run this, and I have this. Now this one looks more beautiful, true or false? You can agree with me that this one looks better. The one I have now, it looks fine. The curve is no longer that rough like this one. It's smooth because I use 100 data points. If you have a equation, you can drop it in the comments, this thing. Now let me show you one thing you might not really recognize, but let me show you now. If I do this 12, if I change this to 12 and run it, the text is going to move. When you see the text move, I'm trying to show you like these things are not just there. It works, right? If I change this to 15 and click on run, you see where this thing goes way down, it goes below. So all the codes here they work. If I change the font here to 15, it's going to look bold, more bold. Can you see that? This text changes, it becomes more bold. So if you're looking at my screen right now, you can, that's it. Let me quickly paste my original notebook right here. Okay. So let me take the next part of this. Now the next part is in the next cell, I'm going to show you another thing we can actually add. We keep improving this thing one after another. Let me show you something else you can add. So right just below here, I'm going to click on code and I'm going to paste this and I will explain it to you. So the difference between this one now and the other one is going to be very, very obvious. Let me run it. Now, in this case, I have a red line that cuts across the origins, right? From 0 to 0, 0 to 0, just like in your normal graph. Just like in your normal graph. How was I able to reproduce this? How did I add these red lines? Now, the difference between this code and the previous code that gave us this one is just that okay, what I did differently is that I added this particular part to the code. That's AX H line. That's AX axis horizontal line and axis vertical line. From 0, color should be red, line width is 1. Axis vertical line, 0, color is red, line is so. I believe right now your brain is going to be like, how is he able to remember this? What's this all about? It's not so difficult. I tried to explain from the beginning. PLT is the matplotlib I imported here. Let's go to the beginning. PLT, right? And then all those things, figure, axis line, they're actually found in something we call documentations of a package. You don't need to cram them. Before I close this video, I'm going to show you where I got all those functions, the documentations, okay? So Xsticks, horizontal line, vertical line. When you add that, you have this. Now I'm going to move this text here. Let me move the text a little bit. You know where I should change it right from here. So I'm going to make this thing -1 and I'll run it. If I make it -1 and run it, can you see where the text is now? The text is up. Then I'm going to make it let's say 2, run. See where it is now, and that's okay. You see, so it's done up. So it looks more like the scientific graph you make in classrooms. Now, before we really call it a day, let's have this other part also. Now, I'll run this and they're going to tell me the difference between this one and the previous one. What do you think is the difference between this one now, the one I have here, and the one I have here? Is there really a difference? Those following, if you can see a difference, just tell me. What's the difference between the both of them? Is there really something we can call a difference between both? Let's see how tricky it is. Is there a difference between this one and this one and that one? Okay. Now, part of the difference is position of the text. Now, in this case, the text changed uh, because I changed a value here. It moved the text to somewhere else. The text is moved somewhere else. Okay, and that's part of the difference. Apart from that, there's really no difference between the both of them. So why did I show you that? Just to show you that there are different ways you can actually customize those things. And then lastly, let's have this. Now I have added something else. Please, if you are still, are you still with me? If you are still with me, okay, very good. Some persons are still with me. That's okay. Now, if you are still with me, we have done a whole lot of stuff. And some persons, for those that are just joining us now, I would like to go ahead and explain, give you a basic explanation of what we have done so far. Now, in this particular chart now, I've been able to create something that looks let me not use exactly, but almost like what we do make use of back then in school. This is like a graph. You have the title, you have the axis, y-axis, x-axis. I'm even able to label the minimum. If you know about minimum and maximum, I'm even able to add the equation, okay, to the this thing, the plot, and the horizontal and vertical lines are there. Here is we started from this place. When we started making this plot, it was looking as plain and as naked as this. Now, due to the knowledge of the package you are using, we've been able to make it look this okay. We've made it look this better. Now, all of a sudden, we've been able to make changes now, right? And we now have this thing. We now have from looking so naked, sorry, from looking so naked like this, just plain like this, we have been able to add almost everything. We added minimum, we added the equation, we added the x-axis, y-axis, we added grid lines, and I know I can actually make this thing look better, but so far so good. I think this is just exactly similar to what we made back then in secondary schools. So I asked us then, what is the difference between this particular chart and this particular chart? Now, this is the difference. In this particular chart, how I wrote the code is the difference. I kept making use of plt.plot and all. But when you look at this chart, it's somehow different. Instead of plt, I now have ax.plot, ax.set label, ax.set y label, ax.set title. Why am I making use of this one? So I'm going to explain this one. Now, this part of the code is not different from this one so much. The only thing is that the PLT we do call often, I assigned it to a variable. Don't get confused. If you're going to work with Python, you must know what variable is. A variable is just you saying, for example, y is equals to 2x. In that case, y is the variable containing 2x. It's just it. So the variable is a box that is going to contain information. If I say that x is equals to 50, it means that x is a box, x is a variable, and I have added 50 into that box. It means that whenever I call x, x will now be what? 50. That is it. So by saying that fig and ax is equals to plt.subplot, what I'm trying to say is that whenever I want to call plt, I can actually call what? Ax or fig. So right here, I did ax.plot x, y label quadratic, which is similar to plt, dot plot x, y, that exactly almost exactly that, very, very similar. Exactly. Now, so that's all I plan to show us today. Where's how many persons do I have here now? Okay, I can see 7 persons. Many persons are joining now. Okay, oh. So Jenny, I like your spirit. So please, some of you should go ahead and look up the this thing, the notebook. Now, quickly, I am going to show you the other thing we have for the night. Let's quickly take this part. Um, okay, yeah, that's it. So please. Mm, let me show you some other stuff. So I promised you all that there are okay, let me share screen. Yes. Now, those that joined at the beginning, we tried showing some other plots. I showed you some packages rather we can actually make use of. So I want us to look into those packages now. One of the packages is Seaborn. So Seaborn is actually package, yes, for data visualization. So with Seaborn, you can actually make awesome, you can make awesome charts like you can see now. You can make your box plot, you can make your some of you can recognize this plot. You can make your box plot, you can make your pie charts, you can make your name them just with Seaborn. Okay, now the next one we're going to talk about is Plotly. Plotly Python. Plotly is another package, a very, very good package for data visualization. And it's why I like Plotly is because Plotly makes your, it gives you an interactive visualization. By interactive, I mean you can actually click on it and you are going to see changes, right? Like, let me show you. It's loading. I don't know why the network is affecting it, but give it some time. Oh, I don't know why network. It's okay. Okay, why network keeps disturbing us? Let me show you. Lastly, let me just show you one of the plots I made with Plotly, so you can appreciate what Plotly can do. So this is it. Uh, let me try running this. Run all, and let's see what we can have here. Okay. So sorry. It's I'm really having serious network challenges from this end, and it appears it's affecting. Okay, this part of, okay, yes, it's working now. Now this part of a kind of project I worked on back then, which I'm showing you now. To I just want to show you the difference between Plotly and something else. And my Plotly graph, it's they have not loaded yet. I don't know exactly why network is disturbing it, but that's it. So please, I will appreciate your comments anyway in the this thing. I will appreciate your comment in the comment section so far. I don't know what you have been able to do. I do not know. But then whatever you have, like, let me have your comment in the comment section. I'm going to drop a link to a Telegram channel. In that Telegram channel, I'm going to drop what I did now is just an introduction. We might not be able to cover everything. But right in that Telegram channel, I am going to do this thing. I'm going to um, I'm going to in that Telegram channel, I'm going to carry everybody along on just one more free class. I promise you, just what? One more free class. And then in that free class, we're going to go beyond just what we did today. What we did today is appreciation. We just try to appreciate the tool. I assume everybody is a beginner, we have little or zero knowledge. So, but then in that particular class, you must have read some of the book, some of the things I am going to send across. Okay, and then we can then go ahead and do a sample project. So when you do that, you'll be able to actually tell yourself, I can do something in what Matplotlib with Matplotlib and then with Python. So quickly click on this particular Telegram channel. Let me have you in that Telegram channel. Whether you got my mail or not, everything, every resource will be totally displayed in that in that. Okay, if even if you came late now, no problem. Yes, it's Jupyter Notebook, but a cloud version of it. Okay, it's on this thing, a cloud version of it in Cargo. Yes, so I like it because you don't, whether you have a poor system like a system that is not so good. Once you have network, you can still do your Python for data visualization. So it's right there on Cargo. There's also another version which is Google Colab. But let's make use of Cargo for today. So please click on that Telegram channel. Let me have you there. And I'm going to continue the class right there. Okay. I'm going to send all the needed resources, all the NumPy and Pandas primer. For those that missed my mail, I'll send it there again. You watch it. And then within next week, right? Yes. What's the difference between MATLAB and Python? Okay, Mr. Zachary. This thing, MATLAB is good. But MATLAB is not really a programming language. MATLAB is more of like a software for analysis. But Python is a programming language, and Python is preferred, okay, because it's a very robust language. Okay, you can use Python for machine learning. You can use Python for artificial intelligence. You can also use Python for development, building websites, and you can use Python for data visualization. And actually, there are packages in Python that allow you to do higher data analysis. Like if you want to do confidence interval, you want to do all those terms in scientific research, like confidence interval, you want to calculate p-value, you want to do ARIMA and the likes of them, time series analysis, you can do that with Python. You can do it very, very well with what? Python language. So I'll please just ask your questions. I would like to have questions at this point. Okay, so you do that with what? Python. And then so I prefer Python. Another alternative to Python is R. R is also a language that allows you to do what? Analysis very, very well. Okay, and it's a very, very good language. But I learned Python, so I prefer Python. I work more with Python. Okay, so that's all I can say for today. If you gain something from the video, thank you so much. And then I won't like to waste our time more. The next announcement is going to hold in that channel, and that's where we can continue. So thank you and see you. Thank you so much for coming for the live stream. Okay. And